Hello everyone and welcome back. So in our last lecture we have learned what is null space and range space. So in this particular lecture we are going to learn what is nullity and rank of T. So in short, null space or another name is what? Kernel of T. So null space is a subspace. So if there is a basis in the null space, the number of element in the basis set is called what? Nullity. So similarly, range space is also a vector space. So if the range space has a basis, then the number of element in that particular basis set is called what? Rank of T. Okay, so let's get started. Now nullity or the another name is what? Dimension of n of T. So we know that what is dimension. So I'll suggest you, before coming to this particular lecture, you first complete the basis and dimension in a very clear way. Do some problems of basis and dimension, because the similar kind of concept we have to use here. Now let U and V be two vector spaces over the same field F. Then after that we have to take a transformation T from U to V. So T is a linear transformation. So I think you all remember what is the definition of transformation. Okay. So T is a transformation from U to V, be a linear transformation. Then nullity of T is the dimension of null space. Okay. Dimension of null space. So this is the actual definition. Dimension of null space. So what does it mean? Suppose this is the null space n of T, and then there is a set S. If S is a basis of n of T, then dimension of S is called what? Nullity. It is denoted by nu of T. So first we have to get a basis in n of T, and then we have to check that what is the number of element in S. So that number is called what? Nullity or dimension of n of T. So this is the simple definition, dimension of null space. Similarly, when we talk about range space, so here also we have to take a linear transformation from one vector space to another vector space. Then what? Dimension of range space is called what? Rank of T. So this is U, suppose this is V, T is a transformation, this is our range space R of T, and then inside this, if we have a basis, suppose this is a basis, S is a basis of R of T, then in S how many elements are there, we have to check. That particular number of element is called what? Rank of T, and it is denoted by what? Rho of T. And then there is one theorem which is called Sylvester's theorem. So depending on that particular theorem, we can say that rank of T and then nullity of T is equals to what? Dimension of U. So we'll verify in one problem. So let us come to the problem and see what are the problem says. Okay, let us come to the first problem. Here you see what is given. Capital F be the field of complex number. So it's a field, means a field of scalars. So whatever element you will see in F, all those elements are complex number. Also we know that all the real numbers are also complex numbers. So in capital F we have real and as well as complex. Now complex number means what? A plus I before. And what is T? T is a function from which set to which set? So here T is a function from F to the power 3 to F to the power 3. So 3 dimension to 3 dimension. And this is important thing. What is defined here? x1, x2, x3. So x1, x1, x2, x3 is from domain. Its image will be what? x1 minus x2 plus 2x3. So this will be in codomain. Describe the null space. So here no need to find nullity. Here we have to find null space, means n of T. So I think you still remember what is n of T. Just recall the definition, n of T. In n of T, what kind of element will be there? those elements of f cube whose images are t of x is equals to what? 0 dash. What is 0 dash? 0 dash is the 0 element of f cube. So to find the null space, let us take an element, let u equals to x1, x2 and then x3. Why we have to take x1, x2, x3? Because these are element of f cube. So belongs to f cube. We have taken an element from what? Null space. Okay. Okay, null space. So according to definition, what is t of u? T of u is 0 dash. So what is 0 dash? 0 element of f cube, the vector space. Okay. So this implies t of u means x1, x2 and then what? x3. So when you write 0 dash, 0 dash is 0 element. So it's an element of f cube. So f cube means 3 dimensional. So it will be 0, 0, 0. Okay. So it's already given that what is t of x1, x2, x3 is given in the question, right? So how much it is? x1 minus x2 plus 2x3, then 2x1, x2 minus x3 and minus x1 minus 2x3. There is 2x2, there is no x3, equals to our right side is 0, 0, 0. Now if you compare, then we will get 3 different equations, right? So after comparing, you see x1 minus x2 plus 2x3 equals to 0, and then 2x1 plus x2 minus x3 equals to 0, minus x1 minus 2x2 equal to 0. So now we have to solve and find the value of x1, x2, x3. So there are 3 equations and 3 variables. So there are a lot of methods by which we can solve this. Gauss-Jordan method, normal matrix method, by Cramer's rule also you can find. So there are several methods. So using any one of the method, we can solve it. So let us write the coefficient 1, minus 1, 2, 2, 1, minus 1, minus 1, minus 2, and then what? 0. And the variables are what? x1, x2, x3. Okay. On the right side, we have to write like 0, 0, 0. So we are writing these 3 equations in matrix form. So after that, what to do? I think you still remember, we have to make these 2 elements 0, right? x3, 0, 0, 0. So first row is fixed. So what to do? R2 goes to R2 minus 2 R1, and then R3 goes to this 1 minus 1 plus 1, just simply added R3 plus R2. Okay, so when you do the operation, what will get? 0, this minus 2 into this, how much it will be? This 0, 0 minus 2 into this, it will be 3. This minus 3 into this is how much? Minus 3. Okay, and then if we add it, 0, minus 3, and then what? 2. So that we will get. So next what to do? Yeah, 2, 1, minus 1. This minus 2 is correct. Okay, next, again x1, x2, x3. Right side is 0, 0, 0. Then we have to make this particular element 0, right? So R3 goes to R3 plus R2. So I think you still remember all these methods because I have uploaded all these methods long back. So kindly practice all these methods, this Gauss-Jordan method, Gauss elimination method, Cramer's rule, so that whenever you need, you can easily apply all these methods. So it's 0 and this is minus 1. Now if you multiply again, so again what we'll get? We'll get 3 different equations, right? We'll get 3 different equations. So our first equation will be x1 minus x2 plus 2x3 equals to 0. This is one equation. Second equation is 3x2 minus 3x3 equal to 0. And finally minus x3 equals to 0. So from the last equation, x3 is how much? 0. If you put the value of x3 here, you see, if you put x3 here, so your x2 will be equal to 0. And if you put x2 and x3, your x1 is equals to what? 0. So all the values are 0. x1, x2 and x3. What is x1, x2, x3? Our x1, x2, x3 is u. We have taken u as x1, x2 and x3. So this is an element of n of t, but this particular element is now coming as 0, 0, 0. So whatever different values whatever value you will take x1, x2, x3, so finally it will come to 0, 0, 0. So this belongs to what? N of t. So what does it mean? It means that number of element in n of t is only this one, 0 element. And what is dimension? Dimension, when you talk about dimension, dimension is number of what? Non-zero element. Okay, number of non-zero element. This is completely 0 element. So if we are asked to find the dimension of n of t, means I am talking about nullity. So here nullity will be equals to what? 0, because there is no element. Okay, so it's here null space is what? So how to write the null space? So null space is only consist of one element, 0, 0, 0, or you can write 0 bar also. So it's better you have to write like this. Now let us go to the very important problem. So I'll do one problem only, otherwise our lecture will be too long. So such type of problem you have to practice, okay? Because this type of problem you will see in almost every exam. So kindly practice this. So here T is a transformation from one vector space to another vector space. So here the first vector space is what? R to the power 4, and the second vector space is what? R cube. So here when you take an element from domain, it will be 4 dimensional, x1, x2, x3 and x4. This is an element of, this element is from R to the power 4. But when you come into the image, so it will be 3 dimensional. You see 1 element, 2 element and then 3 element. Okay, it looks a little bit big, but problems are very simple, don't worry. Find a basis and dimension of R of t and n of t. So we have to find both basis as well as what? Dimension. And also verify the Sylvester's theorem, which is rank of t plus nullity of t is equal to a dimension of V. So try to understand this problem. I'll go very slow so that you can all understand. But before coming to the problem, no, starting the problem, you remember one thing. When you take the R square, no, so for R square there is a standard basis which is 1, 0 and 0, 1. In any book you'll find this. If it is R cube, again the standard basis is like this: 1, 0, 0, 0, 1, 0, and then what? 0, 0, 1. But in our case it is R to the power 4. Since it is R to the power 4, so our standard basis will be 1, 0, 0, 0, 0, 1, 0, 0, then 0, 0, 1, 0, and the last time is 0, 0, 0, 1. Okay, so in almost all the problem you just have to check it's 2-dimensional, 3-dimensional or 4-dimensional. So according to the dimension you have to take the standard basis. So here, since we have R to the power 4, so our standard basis will be 4-dimensional. Okay, so it will be 4-dimensional. So let us take okay. So let here t is from where to where? Our t is from R to the power 4 to R cube. Okay, R to the power 4 to R cube. So we have S equals to, standard basis is like this. Suppose E1 is our 1, 0, 0, 0. Okay, then E2, our E2 will be 0, 1, 0, 0. E3, this will be 0, 0, 1, 0, and the final E4, this is your 0, 0, 0, and then what? 1. Okay, so this is a basis for what? R to the power 4. So this one is the standard basis. For R cube there will be 3 element, for R square 2 element. Okay, so like this it will go. Now if you find the image, suppose T of E1, so T of 1, 0, 0, 0, right? So this is our x1, this is x2, x3 and x4. So if you put these values here, x1 is 1, x2 is 0, x3 is 0, x4 is 0. So what you will find after putting on the right hand side, you will get, to calculate it, you will get 1, 1 and 1. Okay, just put it, because other two values are 0, na? x3, x4, x4, these are all 0. So you will get 1 here also 1, and here also 1. Similarly, we have to find the other element, T of E2. So T of E2. So our E2 is what? E2 is 0, T of 0, 1, 0, and then what? 0. So when you put this, our E2 will be, after calculation, you will get -1, 0, and then 1. Similarly, T of E3, will get 1, 2, 3. Okay, 1, 2, 3. So that will find 1, 2, 3. And then T of what? E4. Our T of E4 will be 1, -1, and then -3. So how will you get all these things? Just put it here, different values. When it is E1, so the values are 1, 0, 0, 0. If it is E2, then 0. This is 1, and then other two are 0, 0. So like this, you can find each and every one. So now we have some new element. Okay, all three-dimensional elements. See, 1, 2, then 3, and then what? 4. Okay, new element. For any x belongs to R to the power 4. So we have taken an element from the codomain. So do you remember what is what we are saying here? L of S is a, see what we are saying, S is a basis of R to the power 4. Okay, just you recall the definition of linear span or the basis. S is a basis. S is a basis of what? R to the power 4. What are the condition? First condition is S is Li, and second condition is very important, na? L of S equals to R to the power 4. So what does it mean? L of S equals to R to the power 4. Any element of R to the power 4 is a linear combination of what? Elements of S. I think you still remember, right? That time also I told you that go through these particular lectures in a proper way so that you'll understand everything later on, because all are related. So any element of R to the power 4 is a linear combination of what? Elements of S. So we have taken an element from R to the power 4. So this must be a linear combination of elements of what? S. So in S, what are the elements? E1, E2, E3, and E4. Then X equals to, suppose what are the coefficients? Suppose A1, E1, A2, E2, A3, E3, and then what? A4, E4. So this is a linear combination. Why we can write like this? Because we have already taken that S is a basis for R to the power 4. So this implies, let us take transformation on both sides, T of X. So it will be T of A1, E1 plus A2, E2 plus A3, E3, and then what? A4, E4. Okay. Already T is a transformation. So since T is a transformation, from the condition of transformation, you can write A1, T of E1, then A2, T of E2, A3, T of E3, and then A4, what? T of E4. So this is equals to A1 into, we have already find a T of E1. T of E1 is our 1, 1, 1. So 1, 1, 1. Then A2. A2 is our -1, 0, 1. Then A3. A3 we have 1, 2, 3. And then A4. With A4 what we have? We have 1, -1. Then what? -3. Right? And left hand side T of X. So in place of T of X, if you want, then you can write Y. Okay, so T of X is an element of range space. So here Y belongs to what? R of T, because X is an element of domain. So its image will be in the range space. Okay, now we have to calculate this and find a new matrix. So here, what are the coefficient? 1, 1, 1, -1, 1, 1. So we have to check that this is what? We have to calculate and find all those values of A1, A2, and what? A3. So for that, we have to find a new matrix, which is called, to check this, this combination. Y is an element of what? R of T. And A1, these are T, E1, T, E2, T, E3. See here what we have written, X is a linear combination of E1, E2, E3, and E4, because we know that S is a basis. But here we have a combination, linear combination, but this is correct or not, that we have to check, because now this is not an element of S. This is an element of what? Range space. And these elements are not E1, E2, E3. These are T of E1, T of E2. So now we have to check that. So a new matrix we have to make now. matrix for this particular set will be what? What are the first element? 1, 1, 1, minus 1, 0, 1, 1, 2, 3, and then 1, minus 1, and then minus 3. So these are the all coefficients of this particular equation. This is a new equation. Okay, so coefficient of all this equation. So we have to check that this line is correct or not. That means whether y is a linear combination of this TE1, TE2, TE3 and TE4 or not. That we are going to check now. So for that we are making one matrix. So I think again we have to use what? Echelon form. So our first row will be fixed. So what we'll do now? It's very simple. R2 goes to R2 plus R1. R3 goes to R3 minus R1. R4 goes to R4 minus R1. Okay. So you still remember that in echelon form first row is fixed and all the operation first you have to do with R1. So these will all become 0, 1, then 2, again 0, 3, and then what? 3, and then what? 4, and then here 0. Oh, sorry, we are subtracting. No, 1 minute. We are subtracting. So it will be your 1, then what? 2, and then minus 2, and then what? Minus 4. So what will be the next step? Now we'll make these two elements 0. So 1, 1, 1, 0, 1, 2. Then what to do? So R3 goes to R3 minus R2, and R4 goes to R4 plus 2 R2. So if you do this, you'll see that all these elements will become 0, 0, 0. So see, actually we have 4 elements, 1, 2, 3 and 4. But when you calculate, no, 2 elements are vanishing. So you'll have only 2 elements. Other 2 elements are 0. Okay. So which is in echelon form? Which is in echelon form. Okay. So from this echelon form, what we see that we have only 2 non-zero elements. Okay. So we have a new set. Thus the set of non-zero vectors. So we are only concerned about the non-zero vectors. Non-zero vectors. What are the elements? 1, 1 and 1, and the second element is 0, 1 and then what? 2. So these two non-zero elements constitute the what? Range space of R of t, or better we can say that this is the basis of of what? R of t. So it's very simple. Okay, all the problems are similar type. I'll give you some problems to do. In the same way, if you proceed, then you'll get similar type of answer. See, if this element is non-zero, then this element also you have to take. Then one more element will come. Now this is the basis for range of t. Now what is the definition? Number of element in the basis is called what? Range or rank. So what is rank here? Rank of t, or the symbol is row of t. So how many elements you see? Only 2 elements. So rank is 2 here. Okay, rank is rank of the linear transformation, or rank of the null space. Range space is how much? 2. Now we will find the basis for what? N of t. So in the same way now we'll do, but for the null space. Okay, so I know that we know that what is null space. So in null space, if we take one element, then image of that particular element will be what? 0 dash. Suppose if we take an element from the null space, so image of this element will be what? 0 dash. Okay, 0 dash is what? 0 element of R cube. Okay, suppose this particular x is from which set? Null space. Null space is a subset of what? Domain. So our domain is what? R to the power 4. So our x will be 4 dimensional. So therefore this x will be 4 dimensional. x1, x2, x3 and then what? x4. This is 4 dimensional element. And t of this 4 dimensional element x1, x2, x3 and x4 will be what? 0 dash. So our 0 dash is 0 element of codomain. Our codomain is R cube. So 3 element will be there. Okay, 0, 0, 0. Now this is already given in the question. What is T of x1, x2, x3, right? It is given in the question. See, x1 minus x2 plus x3, that we have to write again. So this is our x1 minus x2 plus x3 plus x4. Then x1, 2, x3 minus x4. I think x2 is absent. Yes, x2 is absent. And then the last element, which is x1 plus x2, 3x3 minus 3x4, okay, is equals to what? 0, 0 and 0. So we have to compare. So after comparing, see, we will get again 3 equation. So first one is x1 minus x2 plus x3 and then x4 equal to 0. Second is x1 plus 2x3 minus x4 is equals to 0. And then x1 plus x2 plus x3 minus 3x4 equals to what? 0. So we are getting 3 equation. So again, with these 3, we have to make one coefficient matrix. Okay, coefficient matrix. So what is that coefficient matrix? So our coefficient matrix will be, first is what? 1, minus 1, 1, 1. Then 1, x2 is absent here, 2, then minus 1, 1, 1, 3, and then what? Minus 3. So again, what we have to do? We have to do echelon form. So kindly do the echelon form again, otherwise it will be a little bit long. So same procedure, first we will make these 2 elements 0, and then keeping second row fixed, this particular element will be 0. So finally you will get this particular expression. So last will be all 0, okay. So all are coming to be 0. So one element is completely 0, one row is completely 0, but other two are what? Non-zero. Now, so therefore, this is the new form: 0, 1, 1, minus 2, 0, 0, 0, 0. With this we have what? 3 vectors: x1, x2, x3, and right side what we have? 0, 0, and then what? 0. Now if you compare, if you multiply and compare, we will get how many equation? 2 equation. First equation is x1 minus x2 plus x3. Okay, this element is 1 and 0 plus x4 equals to 0. So this into this, compare with this 0, we will get this particular equation. And then second row, you will multiply with this and compare with this particular 0. So next is x2 plus x3 minus 2x4 equal to 0. And third is completely 0. Okay. Now from this, what we will get? From this particular equation, x1 is equals to x2 plus x3 plus x4. Okay. I am taking other 3 factors on the right hand side. And from here, what is x2? Our x2 will be minus x3 plus 2x4. Let us put this value of x2 here. Minus x3 plus 2x4 plus x3 plus x4. So this is cancelled. How much it is? 3x4. Okay. So is it correct? Let me check once again. This is minus, right? So I have made one mistake. Is plus, this is minus, and this is minus. Okay. So from this equation, I'm writing this, and from this equation, I'm writing this one. So from this particular equation, let us find x2 and put x2 here. So since this is negative, so our answer will be different. Now I will get minus 2x3 and then x4. Now what we are seeing here? Here you see x1 is a function of x3, x4. Here x2 is a function of x3 and x4. So both x1 and x2 are dependent on what? X3 and x4. So x3 and x4 are independent then. So x1, x2 are dependent on x3 and x4. That is, x3 and x4 are free variables. Okay. Means independent, are free free variable. So free variable means we can substitute those values. So therefore there is one rule to find the nullity of t. So it means nu of t. So this is nullity means what? Number of free variable. Okay, number of free variable. So how many number of free variable we see here? Only 2. So nullity is how much? 2. Okay, so nullity is 2. Now to find n of t, what we'll do, since 2 free variable, what we can put here? Either 1 0 or 0 1. So first let us take x3 is 1 and x4 equal to 0. Then what is x1? If we put then x1 will be how much? X1 will be 0 and x2 is also 0. Or we can put x3 equal to 0 and x4 equals to what? 1. Okay, we are putting x4 equal to 1, right? Sorry. So this is 0. So this will be our 1. And here is how much? 2. It's not 0 0, 2. And then if we put x3 0 and x1 is 1, then how much you will get? Let me calculate it again. Maybe there is some mistake. 1 minute. Okay. So what we are putting, x3 equals to 1 and x4 equals to 0. So our x3 will be, if we put here, it's minus 2. And x1 is minus 2 and x2 is equals to how much? This is our x2. Okay, so it's how much? Minus 1. And then we put x3 0 and x4 is 1 1. Why 1 0 0 1? Because for 2 dimension the basis is like that, 1 0 and what? 0 1. Now here what is x1? Now x3 is 0. So if we put x3 0, x4 is our 1 and x2, so x2, this is 0. So how much it is? 2. So we'll get 2 new vector. Okay, so now n of t, what is n of t now? N of t is, what is x1 for this particular set? It's minus 2, minus 1, 1 and 0, one element, and the second element is 1, 2, 0 and then what? 1. Okay, so how many elements you see here? 2 elements. So that's why dimension is what? 2. So if you won't use this particular rule, that is number of free variable, from here also you can see that only 2 elements are there. So what is the verification? What we know that nullity plus rank. So nullity is 2, range is also 2, equal to 4, and this is a 4-dimensional vector space. I think you remember this is r to the power 4. So dimension of what? R to the power 4. So this is one problem. So like this, kindly you try these problems. There are several methods, several problems in any book you will find. So practice this problem. Same from r to the power 4 to r cube, that problem is a little bit big. So that is why I have taken that particular problem. Here you see all r cube and r square, so smaller part. So kindly finish all this problem by yourself. Okay, so if you have any doubt or query, then you can ask in the comment box. So I hope you like this particular lecture and it's helpful to understand what is the rank and nullity. So thank you for watching the video till now, and if it is helpful for you, then kindly share with your friends also. Thank you very much.